Hey guys, in this video I'll be going over the problem my calendar 1. So this problem asks you to implement a class that essentially represents a calendar, and you will need to add events into your calendar. And so events will be represented as a pair of integers start and end, and that just represents the time that there's a booking, right? So it's inclusive of start but not of end, and the class needs to basically have this method called book with a start and an end, and if you can book it, then you add to the calendar and return true, and otherwise if there's an overlap, they call it here a double booking, when two events basically intersect, then you return false and don't add anything. So this problem has pretty straightforward, and the only thing to note here is even though this block here occupies from time 10 to time 20, you're still allowed to add something from time 20 to 30 because it's not inclusive of the endpoint. So, so yeah, this is allowed because it'll go from like 10 to 20, but since it's not inclusive of 20, it'll go 20 is still open to be booked from the start here. But of course, this will return false because you know 15 will already be booked inside of this thing, so there will be an overlap. So the trick here, so now we're going to go into the solution. So the trick here is to essentially keep our bookings sorted so we can use binary search to find the booking just before or just before it. So we want to sort our booking list because when you add to the calendar, we're just going to use a list for that. So we're going to have a list of these bookings, and so let's just say we have a list here. So this represents like a list, and so whenever we add a booking into it, we want to just add it and keep it in sorted order. So that way, when we want to check if a new booking comes, instead of looping through the list of bookings to find the booking just before it, since our bookings are sorted by start time, we can use binary search to find the booking whose start time is just before this new booking. So that way, that helps us because if we know, like, let's just say we have a start time of 15 and we want to and a start time of 20, and we have a new booking with a start time of 18, what we want to do is we can use binary search on, well, this is a small array, but you can imagine this would be a large list of bookings, and we can binary search to find this event, because this event, we know that this event starts at time 15. It is the event just before the event we want to add. And so then we can check if this event just before, if its end time is earlier than this start time. So let's just say there's a booking here with start equals 15 and end equals like 17 or 18 will rook 2. It just has to be less than or equal to this. So if the end time is less than or equal to this, then we know, yeah, this booking can be booked and we can put it after this. But we also need to add a check if this booking overlaps with the booking just greater than it. So because we know this is the one just less than it, we can like basically use that information to know that this one should be the one just greater than it, because when we binary search, we'll find that perfect spot inside of there. And it is worth noting that if we already have an event which starts at 18, like if there's already an 18, well, you obviously can't do that because we can just automatically return false there because there will be an overlap on 18 because it's already booked. So then we can check for the event that is just greater than it in terms of start time, and we need to make sure that this start time occurs after this end time. So let's just say this represents an event that starts at 20. We don't really care about the end time for this example, And what we want to do is we want to make sure that this event, we know it starts at 18. We want to make sure that this event's end time is less than or equal to 20, so it doesn't overlap with this event. And if it doesn't overlap with either this one or this one, we know we can just insert it right at this index. So now let's take a look at how that's implemented. So we'll have first we'll just make a class called booking to help us out here. It'll have an integer representing the start of the event and the end of it, and just a constructor here. And so when a new instance of this class is made, we'll just initialize this as a new list, and this will represent our list of events, right? And when we want to book something with a start and an end, we'll first handle a couple, like, well, just this one edge case where if bookings is empty, we know any booking will be valid, so we can just add it and return true. So we just have a check here for that. Otherwise, we get the index of the element just before it. So we have the method getIndex, which just has a simple binary search here, where we search for the index just of the event with the start time just less than the current start event. So as you can see, we're binary searching on this start, and so left will represent the booking with the time that is and our left variable will narrow in on the value of start that is just greater than our current start, because if start is greater than it, left will be the middle plus 1, and right will narrow in on the start value that is just less than start, because let's just say our middle element start is greater than our current start, then we won't go into this case, we'll go into this one, and right will be that middle element minus 1. So eventually right will come down to the booking whose start time is just before our current start time we want to add. So we will get the index, and if the index is less than 0, that means we know our event we want to add, well, there's no element before it, because that just means that we're adding it. It's the event that starts the first. So let's just say an event comes in with like start time of 5, then our index will be negative, because we'll know that it's supposed to go here, and there's no element before it because it's the first one. So in that case, we can just check if its endpoint overlaps with this one. So if its end is earlier than this guy's start. So we can just look at the first guy's start and make sure it's greater than or equal to the one we want to add, the endpoint. And if that's possible, we add it and return true, otherwise return false. This is the other edge case when it's the very last event. So in this case, we just need to check if the last the start time of the last booking, we can just look at that one, and we just need to check if this one's end will be less than our new booking's start, so to prevent that overlap, because if we want to add a new event to the very end, we just need to make sure that this guy's start time is after this guy's this guy's end time. And otherwise, we have a normal case, we can just check to see if this index dot end will be less than or equal to start, because again, this index is the element just before it. So if this guy's end is less than the start, and if this guy's start, the next one, is greater than end, so essentially that means that this new booking can fit in between these two, so its start won't be overlapping with this end, and its end won't be overlapping with this guy's start. We can fit it in between these two bookings, and so we can add it at that index, because we'll use index plus 1, because index will point to the index of the element whose start time is just before it, so we know it belongs in index +1, like that spot. So we can insert it at this index and make a new booking for it and return true. And this is just you just return false because we haven't been able to return true in this, so there must have been an overlap. And so doing like this, we'll always maintain that our list of bookings will be sorted on start time, which makes it so we can use this binary search approach to not instantly, but figure out in logarithmic time if you can add a booking or not and avoid these double bookings. So I'm going to submit this. So the runtime of this, well, it'll obviously depends on how many calls it'll make, but each call will be, well, getting the index will be log of n. But I guess if you insert it at the very start, you'll need to shift over elements in the list because you're inserting it here. So I guess worst case, it'll be an O of n operation to add a new booking, but since we have it sorted, most of the time it'll be a little faster than that because we can find where to add it in logarithmic time, which is the main trick. And as you can see, it's accepted. And yeah, so that's about it for this video. Thank you very much for watching, and I'll see you later.